Problem statement is X is more difficult to stir and boil slower than Y.
A substance that flows freely but is of constant volume, having a consistency like that of water or oil. The liquid is affected by boiling point and viscosity.
What is boiling point and evaporation? The boiling point is meaning when vapor pressure reach equilibrium with excited atmospheric. For evaporation, evaporation is a type of evaporation of liquid that occurs from the surface of liquid into gaseous. Vapor pressure is a pressure exerted by the vapor molecule in thermodynamic equilibrium with its condensed phase in a closed container. All these three factors we conclude in volatility. Volatility is a tendency of substance to vaporize.
Viscosity is the quantity that describes a fluid resistant to flow. There are four factors of viscosity: temperature, intermolecular forces, molecular size, and molecular shape. First, temperature. Viscosity decreases with heating because the movement of molecules are fast, so it can overcome intermolecular forces more easily and the resistance to flow decreases. Second, there are three types of intermolecular forces.
Hydrogen bonding. Intermolecular attraction between molecules which contain a hydrogen atom covalently bonded to a small and highly electronegative atom. There are two factors which influence hydrogen bonding. First, electronegativity. H bonding in HF is stronger than in ammonia because F is more electronegative than N. H2O can form more H bonding than HF, making H2O to have stronger H bond than in HF, even F is more electronegativity than O.
Dipole-dipole forces. A dipole-dipole forces exists between polar molecules. The positive pole of one molecule attracts the negative pole of another. Factors which influence dipole-dipole forces: molecule polarity and boiling point.
Next, we will go to London dispersion forces. It is the weakest intermolecular force and exists to all atoms and molecules. It is one of the attractive forces that cause nonpolar substances. There are two factors of London dispersion forces. First, molecular size. The second factor is molecular shape. A molecule's shape is spherical, so these molecules make a little contact to each other.
Hydrogen bonding. The electrostatic attraction between the two polar groups, which are atom covalently bound and can occur in intermolecular forces or within intramolecular forces. Affect the boiling point and increase melting point.
Dipole-dipole forces exist between polar molecules. These forces attraction between the negative pole of one molecule and the positive pole of another. The strength of dipole-dipole forces depend to dipole moment. The higher polar molecules, the stronger dipole-dipole forces.
London dispersion forces, the weakest intermolecular force and attractive forces that cause nonpolar substances. The first aspect in London dispersion forces is origin. The second aspect is universal presence. The third is relative strength, and the fourth is molecular shape.
Problem statement is liquido. So we get the scenario is X is more difficult to stir and boils slower than Y.
Next, to compare the substance from different intermolecular forces, we assume that X is HF, Y is CH4. HF and CH4 came from different intermolecular forces and stand-in forces. H4 has higher intermolecular forces than CH4. Thus, H4 has higher viscosity than CH4. So, HF is harder to stir compared to CH4. Since HF has a stronger intermolecular forces than CH4, so large amount of energy is needed to break the bond that makes the boiling point for HF is higher than CH4.
Next, comparison for same intermolecular forces. We assume that X is a hydrogen bromide and Y is hydrogen chloride. Hydrogen bromide and hydrogen chloride are coming from the same intermolecular forces. The difference in force is caused by electronegativity and molecular size. Hydrogen bromide has less electronegativity than hydrogen chloride. Thus, hydrogen bromide has larger intermolecular forces. It makes the size of hydrogen bromide bigger than hydrogen chloride. So, hydrogen bromide has higher viscosity than hydrogen chloride that makes hydrogen bromide is harder to stir.
Next, HBr boils slower than HCl because HBr have a higher boiling point than HCl. So HBr need more heat energy to overcome compared to HCl.